Welcome to the topic. So today, we'll see complex data types in OODB. So before starting into the concept of OODB, let's have a basic understanding, like how does this OODB is differed from RDBMS. Okay, so where we'll be having a database in a relational based. So in that actually, so when you just to declare a structure with the relation database management systems, we have two approaches actually when you're considering regarding database management. So which is first one is your object oriented database, the second one is your relational database. Okay, so each thing they have the unique features and the weakness. So here we'll be having an okay. So regarding your RDBMS, so where which you will be like representing all the datas in the tables, which means the relations, which consist of rows and columns. So all datas will be like loaded into a table structure, which is like rows and columns. We could not able to get a relationship among the attributes. Okay, so each thing will be like represented as a single attribute, so that we're not able to extract the relationship, but it has some unique features and benefits. But we when we are just speaking about key value pair like MongoDB, all these things, okay, map key, all these things. So in this case we could not able to do that in a relational database management systems. It is basic, it is a foundation of DBMS, but it is not an advanced DBMS. That's the thing actually. So that's why we slowly move to the concept of OODB, which is nothing but object oriented database management systems. So in this regard, so the structure or data modeling where which each data will be represented as objects. Okay, so similar to that of C++ and Python. Okay, each object, okay, they consist of the data and models, okay, for processing the data. So in that kind we require more complex structures and relationship, okay, which aligns with the object oriented programming principles. So unlike a relational database, which is ODBMS, which relies on tables and rows, the OODBs store data as objects that can encapsulate both data and behaviors. Both behavior and data and behaviors can be encapsulated in terms of object. Only if you represent the data as an object, then only we can do all these encapsulations, inheritance, all these things. Okay, so that's why we are slowly moving to the OODB, which is an advanced database actually. Okay, so regarding the query languages, so often like we are lacking with a standardized query language is SQL. Okay, so in that SQL we have some drawback with that, okay, which is a very foundation. But regarding the OODB, which follows the query language called OQL, okay, that is nothing but object query language. Okay, for that queries, okay, to which has been like performed by using some language methodologies to to just map the database with the applications. For that we require some data structures, okay, or else I can say that data types. Okay, when you are just speaking about the OQL, which is nothing but object query language, so here we'll be like representing a data as an object. In that regard, the data types will become a complex data types. Okay, so where we'll be like speaking about that kind of complex data types in this video. Okay, so here OODBs, they enables the modeling of rich data structures and relationship among the objects. So now we'll see the first one, which is nothing but a collections. Okay, so this is your this kind of a feature. Okay, to achieve this feature we need to follow some complex data types. What are those data types? Okay, we actually in Python we have a data structures. Okay, the type of data structures is list, then set, dictionary. Okay, all these things are your data structures. Okay, all these things are data structures. The same way in OODB also they have a set, list, okay, arrays. Okay, in Python we have tuple, okay, but here they are following arrays and dictionary. So these four are the important data structure for storing a group of objects. Okay, so now we'll see the first one is. Okay, let's have some example over here. So always your thing, okay, so where we have a collections, right? So collections will be like a followed by a set and the list. Okay, so we'll be like having list over here. So list has to be represented by using a square bracket, okay, and set has to be represented by using a flower bracket. So you can see here a library, okay, library here is an object, okay, so where we'll be having each thing, okay, each book, it says collection, actually library is a collection set of objects. So here we have represented name of that particular library, and book is nothing but it is a collections of books, okay, various books. So here each book is an object, but here it is a collections of list of books, okay. So that's where we can just store n number of multiple objects at the same time in a list. That's why we have represented here. A list is nothing but, okay, list maintains the order, okay, so where we can just have the multiple objects in the order and we can just store it in the list, okay. That is where we will be having a list concept, and set is nothing but you can just avoid duplicates where you have all things in a unique way. And dictionary represents a key value pair. Key is nothing but where we will be having a key and with a value, so we can map the key and value for that. So MongoDB, they follow this kind of concepts. Database of MongoDB is a key value pairing, okay. And then so this is example for the list, okay, and the objects. Next is like we can load the object in a nested way. So here objects can contain other object and attributes, okay, so we can just load the objects inside the other object. So where we can have the nested structures. For example, you can just have the employee, okay. So where which employee is nothing but for an university we can have n number of employees. So each employee, they have their own records. Again, they inside the employee is an object. Inside that employee we can just load the other whatever the values we have for that particular employee, we can load it. Okay, so we can just see an example over here. So person is like we'll be having a person is an object actually, it's an object. So inside that we have mentioned a particular person, okay, so we can just load it as a set. So which means that each object or each person or each employee is represented as a single object. So again inside the object, so person is one object, it's a generalized object, and this nothing but a person, okay, where which name is Alice Smith. Alice Smith is a person actually. He is actually comes under the a specific object of that particular person. Okay, again we have address. This is also an object. Okay, we will be allowing you to store a specific person details. So this is an object we are loading inside the generalized object person. Okay, again we can have other name like name XYZ, something like that. We can have it like each person, they have their own address, they have their own contact number, they have own qualification, all these things. Yes, so we are just loading the one object within the other object, that is your nested object. So here address is a nested object within person, allowing us to store the hierarchical informations. Okay, so we can have like if we are having a family, family is an object. Inside the family we have a parent, son, okay, name of the parent, and then qualification. So each thing will be having a unique characteristics or unique features or unique objects of particular persons. Okay, so in that way we can load all the informations in the hierarchical way. So hierarchical informations in the OODB is represented by using a nested objects. Okay, this is your data types of loading the hierarchical informations. Next we'll come to the relationship. So relationship is nothing but where we'll connect, okay, one object to the other object. So where we'll be like mapping up one object with the other object, like in a Facebook you can see that. So we have like we have an account and inside that we have a friends, okay. So each thing like we are connected to the our friend circle. So our informations can be accessed by my friend who is connected. So we will be like establishing a relationship between me and my friend. Okay, that is I am the object now, my friend is other object. So where which we will be like establishing a relationship between each objects. So we can have a different types of relationship which is nothing but one to one. One to one is nothing but where we when we have connecting to face. Okay, so like so I can just say that me and my friend, okay, where which I have a conversation between me and my friend only. So one object to one object only. Okay, one to many is nothing but when like for example, if you take an HOD and under HOD we have multiple many employees are working. Okay, so one HOD is giving instruction to the many employees. So that is not one to many, which means that one department have one many employees. Okay, that is one to many. So many to many is nothing but we can have when we have a multiple employees and to the multiple departments, something like that, tie up with the multiple thing. So or else we can just have that many to many relationship in somewhere, like where we'll be working with multiple projects, so say, or like in that kind of thing. So many employees working with many projects. So when we have the such kinds of thing, then we can just say many to many relationship. So that relationship can be explained by using your object oriented set, okay, data structures. So you can see here we have a class object relationship. Okay, so in object oriented, to mention or to manage your references and relationship, you have to use that, okay, object reference over here. So you can see here, so we have a student and we have all these things. So this particular thing, this student where it is reference to the particular object, and then that object has been given here. So that description is given over here. Okay, class name. So this particular student is working or is studying in this particular max subject. Okay, you can just, okay, you can just give the department also, for example employee. So you can just give the name. For example, you can just give employee. Okay, employee, you have to give in a caps letter. So employee, he's actually thing is like an employee. You can change it over here. Okay, I can change over here now. Okay, I have employee. So for a name, I can give my name. Okay, and I can just give class ref. So I can just give, so class name, I can just give a department name over here. Okay, I'll just give Sintel. Okay, so this description of this, it is here. Okay, so class name is Sintel and we'll be having HOD over here. So that description, okay, this can be used by multiple employee. Okay, this, there's nothing but one to many relationship. This is my one class. This class can hold many objects. Okay, so this is a nested object. So this department, they have this particular department, they can have multiple employees. So under employee, I can load all the employee name of this department. So I'm going to map this employee with this department. When this is getting mapped, no, then from this class I can just map this employee to over here. Okay, so I can just, in this case I can just give multiple, okay, comma. By using comma I can just represent some other name also. Okay, okay, like this also I can represent by using comma. Okay, so which means that all three employees are referring to the department center, and this particular description is given here. So you can just, again, you can add more attributes over here. Okay, so department and university names, all these things. So this one description, okay, can be loaded with like a functions. Okay, so the same thing will be like referring with the relationship. So these employee can be mapped with this class. So these are the object, this is class. Okay, the object is mapped with a class by using this kind of reference, class reference. Okay, so that is a concept of relationship. So class ref in the student object is a reference to the class object. So where which we will be like establishing a relationship between the employee and the class. So here through a relationship thing called class ref. Okay, now next is like inheritance hierarchies. So inheritance hierarchy is nothing but, so a special thing like when you are speaking about object oriented, so which give more benefit for the real time solving real time problems. So OODB supports class hierarchies, allowing a derived class to inherit properties and from the base class. So base class is like we have a, for a generalized base, from that we can just derive some features and we can just customize to our thing. That is your inheritance property. Okay, we'll be having a parent class. From the parent class we can extract various features and we can just create a child class. So here OODB is very high flexible in handling these kinds of relationship or the inheritance benefits. So you can see here we have a base class. This is your base class. Okay. So base class is a vehicle. So vehicle is like we have given a manufacturer and we have given the model over here. These are the attributes. So this is your base class, and now we have an object car. This is your thing, like this is a several objects which derive some features from this particular thing. Okay. So car extends means that this is your derived class. Okay, extends derive some features from the base class. This is your base class. So this is your derived class, and this is your base class, and extends will extend the properties from the base class. Okay, so from the complete this thing property will be utilized by car by adding some features, nothing but number of doors. Okay, now this can be added with this, along with this the generalized or the default features. Okay, this is a customized now. Okay, now we are customizing the doors of this Toyota generic model. Okay, again we will be like taking up the bicycle, so where which we will have some properties from the thing, like we will have something like added up with the particular features. So again this is also an derived class, and this is a base class. So we can have multiple derived class, we can have one parent class or one base class. From that we can inherit some properties. So car and bicycle inherit properties from the vehicle, but also have some additional features along with that. Apart from these two features, we can add up. Okay, when you're deriving, so we can derive some features from the base class, and we can add some additional features or unique features to the derived class. So this is your inheritance facilities given in the OODP. And then composite objects. So composite objects is nothing but where we can have the multiple objects into a single and large object. So when we have an car, okay, it's a single object. So inside that single object, I can load multiple objects like engine. It's also like a nested object. But here we can have more than one or two objects. Okay, where we will be like representing the sub objects. Each part they have their own attributes and methods. Okay, you can see here car. So this is an object. Inside that we have a model is given, and then we have the other object, and again we have one more object. Again within this object, again we have multiple objects. So we'll be like explaining a detailed features of each and every objects in a depth way. Okay, so that is your composite objects, which gives you the complete understanding of your object. So when you are going with having a depth and a detailed view of an object, so to have some clarity for the real time problem solving, then you can use composite objects. Okay, so this is where you will have been having composite objects. Next is like multimedia and geospatial data types, which includes your multimedia components like photographs, then geospatial is nothing but mapping. Okay, geo mapping, your temporal images, audios, videos, all these things. So that can be allow you to store. Okay, so this is a special type, okay, where which it allows for the advanced featuring and to complex data forms to store all the thing, okay, which requires a more number of computing and more number of accessing facilities as security. All these things includes for storing and supporting the multimedia objects like images, audio and video, geospatial data types, all these things. So for that kind of thing we use a file path, so where we will be like mentioning your complete locations for geospatial and the images, all these things. So for that we will be having an object, inside that we will be mentioning the album name, and then inside the again we have like it is completely composite objects, but here we will be like loading an image. That's why we are having a multimedia component over here. This is your this represents your multimedia data types. Next is your custom data types. Custom is like it is completely user defined. You can define, and it is high flexible to have an unique requirements. So we can just have that customized features. So when we have an object, so inside that object you can just specify what are the types, what are the attributes that you can just bring up for that particular based upon your requirement, project requirement, all these things. So in this example we have a patient is a object. Inside this we have a blood type, which is a custom type. Actually this is not a default thing which is not there as attribute, but here we are as a user thing we are defining this data type. Okay, blood type is a custom type with specific fields which have type and RH factor, which is created to store some blood type information preciously. Okay, so this is your customized data type. Okay, which is defined by the user. Okay, it is not inbuilt. Okay, we are going to define that. So these are the complex data types which allow the OODP to handle sophisticated and interconnected data structures. So we can just use this for enhancing your hierarchical inheritance, then storing complex data models, all these things. So this is like highly apt for your real-time problem solving, because real time data is completely unstructured. So in that kind we can just we are using OODBMS completely very complex to have all these kinds of relationship to be declared within that. So I will just go with the advanced database, which is nothing but OODB. So that's it. Okay, so we have seen, I just summarize it, we have seen the collections of data types, list, sets and dictionaries. So we have seen also the nested objects, so object within the object. So you have to follow the same syntax followed with your capital letter for the object, and we have to mention the class names, all these things when you are just going with references or relationship. And this can be used by multiple objects. So this class can be represented, this is nothing but one to many relationship, and based upon your relationship we can just define this the class references in such a way that how the relationship is going to be, it's be one to one or one to many or many to many. Okay, and also we have seen the inheritances, so where we'll just have the concept of base class and derived class. We can declare one base class and we can have multiple derived class which inherit some properties from that, and also we'll be adding up along with that some additional features. Okay, and multimedia, so we have also provisions to store the photos, videos, all these things, geospatial, all these things. Okay, thank you.